Good morning, students. Welcome to our maths class. The chapter 1, numbers. In that, in the last class we have seen the rational numbers and their properties. In that we are going to see the squares and square roots. Okay. Now we know the numbers 1 to 20 I have written. For that we have to write the square. I think you have already studied this square. That is 1 square means 1 into 1, 1. 2 square means 2 into 2, 4. 3 square means 3 into 3, 9. Then 4 square, that is 4 into 4, 16. Then 5 square, that is 5 5s are 25. Like that I have written 20 square. This you have to know. If I asked 12 square means you have to say 144. Then what is the 13 square? 169. Like that you have to say. Okay. Now example 1.25. Find the least number by which 250 is to be multiplied or divided so that the resulting number is perfect square. Also find the square root in that case. Okay. What they asked, this is what 250. Find the least number by which 250 is to be multiplied to make a perfect square. Okay. We shall write this 250 and see we have to calculate this by, what is the method of doing this? Yes, it is prime factorization method. It is prime factorization method. We are using prime numbers to factorize this. Okay. 5. First we shall take 5. 5 table. It is 25. No. You can take 2 also. But I have taken here as 5. 5 5s are 25. 5s are 25 and 0. 50 5s are 25. 250. Then again 5 table 10 times. Again 5 table 2 times. Again 2 table 1 times. So 250 is equal to 5 into 5 into 5 into 2. Here this 5 has pair, so 5 square. Here 5 and 2 has no pair. If it has square means it is a perfect square. Now here it is not a perfect square, isn't it? So if we multiply, if we give 1 5 and 1 2 this, if we multiply by 5 and 2, okay, then it will come as 5 square into 5 into 2. Then I am multiplying extra 1 5 and 2 to make this as a perfect square, isn't it? So 5 into 2. Now it comes as 5 square. Again 2 5s are here 5 square and 2 2s are here 2 square. Okay. Now it is a perfect square because all the numbers, prime numbers, are a square number. Okay. Now we have to multiply and say, what is that? 5 square 25. 5 square, 2 square 4. 25 4s are 100. Then 5 square 25. 100 into 25, 2500. Now you have to see this for as square root. Then 2500 is equal to, for you are seeing the square root for this. Okay. So you have to write this as 5 square and 2 square. Okay. Now take 1 5 and 1 2 outside. 5 5s are 25, 25 2s are 50. For 2500 it is 50. Okay. Then next one. If we divide by 5 into 2, then it will get cancelled and 25. That is 25 is a perfect square because 2 5s are here now. Okay. The next example 1.26. If 108 is a perfect square? Is 108 is a perfect square? That like they are asking. So you have to check by doing prime factorization method. There is 108, 2 table 54, then 2 table 27, then 3 table 9, then 3 table 3, then 3 table 1. Okay, now you write the numbers. 108 is equal to 2 into 2 into 3 into 3 into 3. Okay, here 2 square have and 3 square we have. Then 1 3 is not have a pair. So here 3 does not have a pair. So 108 is not a perfect square. Yes. Then exercise 1.4. Find the square of. You have to find the square for 17 square, 203 square, 1098 square. Okay. So they are given find the square of 17, 203 and 1098. Like that they will give. You have to write like this. 17 square is equal to 17 into 17. That is 289. Then 203 square is equal to 203 into 203. That is 41,209. Then 1098 square is equal to 1098 into 1098 is equal to, yes, 12 lakhs 5,604. Okay, now examine if each of the following is a perfect square. You have to say whether these numbers are perfect square or not. Okay, first one 725. You have to do by prime factorization method. Okay, here 5 table 1 times, then 4 times, again 5 times. Then 5 table 29. 29 is a prime number, so we cannot divide by any other number. So you have to divide by 29 itself. So 725 is equal to 5 into 5 into 29. So this 29 does not have a pair. Yes. So 725 is not a perfect square. Then 841. 841 does not go by 2 table, 3 table or 5 table. So we are 29 sir. This is a prime number. We cannot divide by any other number. So 29 sir 841. Okay. So 29 into 29 square. So 841 is a perfect square. Yes. Then find the square root of prime factorization method. You have to find the square root by prime factorization method. That is root 144. You have to do by prime factorization method. That is 144. 2 table. You can, it is in the last number is even numbers and you can divide by 2. That is 14 is 7. Then 2 2s are 4. Okay. Now then again divide this 72 by, this is 72 by 36, 2 table, and that is 36. Then divide by 2, that is 18. Then divide by 2, 9. Then 3 table, 3 table. Now you write 2 into 2, then 2 into 2. 4 2s are here and 3 into 3. Here 2 square, 3 square. So you can take 1 2 outside, then 1 2 outside, then 1 3 outside. Then square root of 144 is 12. Yes. 4 2 2s are 4, 4 3s are 12. Now this square root comes this side means it will come square. Then 12 square is equal to 144. Okay. Then fourth sum. Root of 1156. You have to do by prime factorization. The last number is even. So you can divide by 2. 5 2s are 10, remainder 1 15, 7 2s are 14, remainder 1 8. Then 578. And again it is a even number. So you can divide by 2. That is 289. 289 is 17, 17s are 289. Okay. Now root of 1156 is equal to 2 into 17 into 17. So you can 2 square into 17 square. You can take 1 2 outside and 1 17 outside. And 17 2s are 34. And this is the answer. Okay. Next one. Fifth sum. Root of 4761. Okay. That is you have to do this by prime factorization method. Now here it is ending with 1. If it is a even number you can divide by 2. But here is 1. So it is not a even number. So it is divisible by 3 or not. For that we have to see, you have to add all this. 6 plus 1, 7. 7 plus 7, 14. 14 plus 4, 18. 18 is in 3 table. Yes. And 18 means otherwise 8 plus 1, 9. 9 is in 3 table. So this number is divisible by 3 that we have studied in the lower classes. Yes. Now we shall apply that here. Then 3 table 1 times, remaining 1, then it will come as 17, then 3 5s are 15, remainder 2 here, okay, 26, then 8 times 24, again 2 remainder, that is 7 times. Again you add this and see, 5 plus 1 6, 6 plus 8 14, 14 plus 7, yes, 21. That is, this number also divisible by 3. So we can divide by 3. That is 5 3s are 15, then 2 3s are 6, remainder 2, then 27 is 9 times 3 table. And 529 is divisible by 23, 23s are. Okay, that you have to know. Okay, then 5 7 root of 4761 is equal to 3 into 3 into 23 into 23. That is 3 square into 23 square. So you have to take 1 outside. Then 3 into 23 is 69. So square root of 4761 is 69. Okay. And we shall see the 6th problem. Root of 9025. 9025. Here also you have to do by prime factorization method. Here the last term is 5. So we can divide this by 5 table. Then 1 times 4, that is 8 times. Then here 2 is not divisible by 5. So you are adding 0. Again this 2 goes to 5. Then 25. 5 5s are 25. Then again the last number is 5. So you can divide by 5. Then 3 5s are 50. 3 30 means 6 5s are 30. Then 5 1s are 5. This 19 19s are 361. That you have to know. 5 into 5 into 19 into 19. So 5 square into 19 square. That is, you have to take 1 5 outside and 1 19 outside. Now 19 5s are 95. So square root of 9025, that is square root of 9025 is equal to 95. Okay, we shall recall. The ones digit in the square of 77. What is the ones digit? What is meant by ones digit? Units digit or ones digit. You can take say as 77 into 77, square of 77. 7 7s are? Yes, 49. You have to do 9 here, isn't it? 4 9, 49. Isn't it? Remainder 4, we have to 4 7 7s are 49, remainder 4, again 7 7s are 49. 49 plus 4, 53. Okay, again 53. We'll do like this, isn't it? Here 9. 9 is the ones place. Have you understood? That is the units place or ones place. So without doing this itself, we can say the ones digit in the square of 77. So square of 77, 7 7s are 49. 9 remainder. So 9 is the ones digit. Okay. Then square of 28 is 28 square. 28 into 28. So 8 8s are, yes, 64. You have to write 4. Remaining 6 you'll add to next one, isn't it? So the ones place for that is 4. Without dividing, you have to say. Without multiplying, you have to say the ones digit of 828 square. Then ones digit of 25 square is 5 5s are? Yes, 25. So 25. So you have to ones digit is 5. Then 10 10s are 100. So the last ones place is, units place is 0. We can say ones digit or units place. Okay. the number of non-square numbers between 24 square and 25 square. Okay, what is 24 square? 24, sir? It is 576. Okay, then 25, sir? Yes, it is 625. Okay, they asked in between this we have many numbers that are non-square numbers, isn't it? 24 square is 576. 25 square is 625. So in between numbers are non-square numbers. So we have to divide. Before 64 you have to see. Sorry, 624. That is from 576 to 624. How many numbers are there? You have to calculate. 624, 576. You have to subtract these two and see, that is 48. So 48 numbers in between this. Okay, that are non-square numbers. Okay, the number of perfect square numbers between 300 and 500 is number of perfect squares, that is 17s are 289. Then 18s are, these are squares. 18 square, 19 square, 20 square, 21 square, 22 square, 23 square. Okay, we shall see. Then 18 square is 324. 19 square is 361. 20 square is 400. 21 square is 441. 22 square is 484. Then 23 square is 529. Okay, 23 square is 529. We need 300 to 500. Here 300 starts from here, isn't it? Between 300 and 500, how many numbers are? Between 300 means here 89. After 89 only 300 will come, isn't it? Here 300 will come. Here 500 will over here, isn't it? So in between this, how many numbers are here? How many square numbers are here? 1, 2, 3, 4, 5. So 5 is the answer here. Okay, 300 and 500. How many perfect squares are there? 5 perfect squares are there. Okay, now we shall see the fourth sum. The value of root 180 lies between the integers dash and dash. Root 180 means 12 square is 144. 13 square is 169. Then 14 square is 196. Okay, before this and this, before 13 and 14 comes that 180, isn't it? Between 13 square and 14 square, this 180 will come. Okay, so between 13 and 14, the integers 13 and 14, root 180 lies between these two integers. Okay, have you understood? Thank you. Have a nice day.